there are sum and difference formulas that you haven't talked about, and then we'll actually have talked about all the formulas on your formula sheet for trig. So, addition of sine, addition of cos, subtraction, addition and subtraction by tan. So, when it asks you for an exact value, but it's not something directly off your unit circle, you might need to use sum and difference. So, for example, if I ask you for sine 45, you can find that instantly on your unit circle, correct? But if I ask for sine of 15 degrees, you could go to your calculator and give me a decimal, right? But if I want an exact value, perhaps there are some numbers on the unit circle we could use, adding or subtracting to get us 15. So we could do like 45 minus 30, let's say. That's 15, right? We have exact values for 45, so we have exact values for 30, so we could do that. So when you use the sum and difference is when I ask for exact values of something that might not be directly on the unit circle, but you can use numbers on the unit circle to add and subtract to get that number. Like 75, let's say, is 30 and 45, right? And those are on there. Okay, so the key thing is being able to recognize them. So how do we recognize this? These are just going from the actual question, the expanded form to the shortened form. So I have sine 48 degrees, cos 17. Cos 48, sine 17. I spot these because they're using the same angles, 48, 17, 48, 17, right? So look on your formula sheet. Are there any formulas that go sine of an angle, cos of a different angle, cos of that same angle, sine of the other same angle? Sine cos minus cosine. Are there any of the sum and difference ones that get you that? Sine what? Same sine A minus B. So if I want to, I can line these up. This would be sine A alpha. That is not an alpha, that's an infinity sign. Sine alpha cos beta, let's say, minus cos alpha sine beta. So these match, and these match. Do you see that? Yes? Oh, that sine answer there is awesome. So this is the same as sine alpha minus beta, right? What is alpha in the case of this question? 48 degrees. And what's beta in the case of this question? 17. So we're going to get sine, sorry, here. Here we're going to get sine 48 degrees minus 17 degrees. Because they want us to write each expression as a single trig function. So like sine of something, cos of something, tan of something, then we're done. That's a trig function. What's 48 minus 17? Sine of 31. Yeah? Done. One is a single trig. I want you to see if you can figure out how these three expanded forms can be made into a single trig off your formula sheet. Try it out. Like this is an cos, technically cos squared x minus sine squared x, right? X being pi over 3 because they're the same. Remember I told you that the people who do well in this unit know what's on their formula sheet? So you almost have it memorized. I know you have a formula sheet and you don't have to have it memorized, but if you know what's on it, you do way better. So, in this case, there's a cos squared pi over 3, sine squared pi over 3. To be honest, this matches the formula cos 2x. If you go to the cos 2x formula down at the bottom, you'll see it's cos squared minus sine squared. Do you see that? The first cos 2x formula. So we're going to go equals cos 2, what is x? What's the angle that correlates with x? What's the angle that correlates with x? Pi over 3. So then this turns into cos 2 pi over 3. Done. Okay. The next formula you can spot has 88, 35, 88, 35. So I'm going to go cos x. I'm going to treat 88 as x. Cos y, every 35 is going to be y. Plus sine 88, so that is x. Sine 35, that is y. Is there any formula that goes cos x, cos y, sine x, sine y? Which one? Cos x minus y. Because there's a plus sign in between, it's the minus one. Yes? So now we are going to write this as equal to cos x. X in this case is 88 degrees. Minus sine y. Y in this case is 35 degrees. So then this reduces to cos 53 degrees. Now this one, we have pi over 12, they're the same. So I could technically call them x if I want, alpha if I want, whatever I want. So I'm going to go 2 sine x cos x. What formula works with 2 sine x cos x? Sine 2x. So it's a double angle sine identity. So up here I'm going to get sine 2 times pi over 12. Which equals, I'm going to take your shoes off if you keep squeaking, pi over 6. I'm going to make the whole table have no shoes. No, you keep socks on. I do not want that. That is excessive. I think the shoes should be tied to the chairs, and then if you want to move, you have to like. Yeah.
Going down the stairs after.
No. At the end of class, they'd be untied. That would be not okay. Just for this time. No, they can walk down the stairs like normal. I won't make you walk down attached to chairs. That's right. All right. Good try. All right.
It's okay.
Shh. So, we're going to talk about these ones. It says, consider the expression 1 minus cos 2x over sine 2x. What are the permissible values for this expression? So the reason why we have non-permissible values or restrictions is I have a denominator with a trig ratio in it, correct? The moment I have a denominator with a variable, I have restrictions. Because that variable can't equal something, because then it would turn my denominator into 0. Okay? So the moment I have a variable in my denominator, you learned this last year in rationals, you can't have that denominator be 0. So the first thing I'm going to talk about is I'm going to say, okay, sine 2x can't equal 0. There are two ways I could do this. So I can think about sine 2x. It's a lot harder to think about. I have to find a spot where it equals 0 and then divide it by 2 to get the answer. Or I can change sine 2x into what? To sine x cos x, technically, can't equal 0. Do we agree? Because that's just a formula on our formula sheet. These are all attached by multiplication, so I can literally put each of these in brackets. And then I can say they each can't equal 0. Okay? Right, let's try it out. So 2 can't equal 0. That's just a true statement. Yes? So some people are like, well, x can't be 0, because that is just 2 can't, yes, you are right. In younger years, in kindergarten, we learn it 0, 1, 2. They are not equal. They are different. True statement. Don't care about that. So the only place we get restrictions is when there's a variable involved, correct? Not a number. 2 can't equal 0. True statement. Cool. No restrictions for that. Then I have my other two. I have sine x can't equal 0. As if it equals 0, my denominator would be a problem. Because technically I have on the denominator 2, sine x cos x, right? And then the other one, cos x can't equal 0. Do you see how there's no restricted domain here? So I'm going to have to give general solutions where x can't be. Yeah, super fun. So, where, and I'll let it be in degrees because it doesn't start. So where is sine x equal to 0? Because we have to say it can't be there. Where is y equal to 0? 0, 180, 360, etc. Negative 180, negative 360, 720. You know what I mean? Just keeps going. Okay, cool. Good discussion. Cos x can't equal 0. Where does cos equal 0? 90, 270, negative 90, negative 270. Now, please listen because people don't get NPVs and they get it wrong on the test all the time, but they're not that hard. I can do these restrictions separately, yes? So this one would be, for this one here, I would get x can't equal 0 plus 180n NEI, right? Do I need to go 0 plus 180 degrees, or can I just write 180 degrees and NEI? Because 0 plus something changes nothing, yeah? So I can go, why do I, so I don't have to put the 0. So I can go 0 can't equal, that's an eraser tool, 180 degrees and NEI. And then for this one, I would say x can't equal 90 degrees. And how long does it take me to get the next one? Plus 180 degrees and NEI. I can write them separately. Okay, in this instance though, I could also write them together by combining them onto one Cartesian plane. So for example, I can move the 90 and the 270 onto here. So then I can actually write sine and cos can't equal 0 together. Yes? How could I do that? The problem is every how many? 90, 90, 90, 90. So I could go 0 plus 0 degrees plus 90 degrees and NEI. Do I need the 0 plus? No. Would I be wrong on a written response? Nope. But you don't need it. Multiple choice might write it like this. So, which one is more correct? The top box or the bottom one? In a written response, they're both equally as correct. In a multiple choice, whichever one is there. In a multiple choice, it might be both of them, because it might be where did the student A, B, C, and D gave the general solutions to the non-permissible values or whatever, right? Who is right? It might be student A and student C, and then B and D did something totally wrong. Right? So on a written response, either one is correct. You do you. Whatever one makes more sense to you. Okay? Now here it says, simplify the expression. So this expression, it's an expression, not an equation, because it does not have an equal sign. Equations have an equal sign. Expressions do not. But expressions will equal each other as we simplify them down, right? That's where you get the equal sign down the left-hand side. All right. So this is an expression up here. So we get 1 minus cos 2x over sine 2x. I want to simplify it. Can someone get the door? There's a lot of people out in the hallway. I don't know what to do. Okay. I want to simplify this down to one of the 3 primary trig ratios. What does that mean? Which trig ratios? Sine, cos, and tan. Yeah, cos, sine, and tan. So it has to break itself down to one of those. All right? So the top one is more confusing to me because there's 3 options. Yes? So I'm going to deal with that one after. So I'm going to go 1 minus, and then I need to replace it with something. So I put brackets. Whenever you replace or substitute in, you get brackets, right? Because brackets say, hey, I substituted it in here. Sine 2x is one option. It's 2 sine x cos x. All right. I need this to simplify down to one of the primary trig ratios. So that little 1 that's sitting in front needs to get out of my life. Because I can't have like 1 plus something or 2 plus something. I want a primary trig ratio, sine, cos, or tan. Yes? So I need to get that 1 to get out of my life. Okay, let's talk about the 3 options we have. We could go cos squared minus sine squared. Okay, cool. Then I would have 1 minus cos squared plus sine. That's not getting me any closer to 1 trig ratio. Yeah? Okay. Then I could plug in this one, 2 cos squared x minus 1. If I plug this in, don't do this. If I plugged in 2 cos squared x minus 1, I have to have brackets because I'm substituting in. Do not do this, you will be erasing it. Okay? If I do this, my next step would be 1 minus 2 cos squared x plus 1. Did the 1's go away? Or do I now have 2? I now have plus 2, correct? Because the 1's didn't go away, because the minus goes to the 2 cos squared and to the 1. Do you see how some people might forget to distribute it to the second one? And then they'll be like, oh, they cancel. And then the answer will be there to that, and you'll be wrong. Okay? So this one isn't a good option, because that will get me negative 2 cos squared x plus 2. It doesn't get me to 1 primary trig ratio. So I can't choose this one. So let's try the last one, which is actually right. 1 minus 2 sine squared x. Why is this one better than the previous one? Because when I distribute that 1 in, or that negative into that 1, it's going to be a minus 1, correct? And what's 1 minus 1? 0. It goes away, right? So when you have that 1 involved, make sure you pick the one of the 3 formulas that will get the 1 to actually cancel off. Okay? So on the top, I'm going to get 1 minus 1 plus 2 sine squared x, because I have to remember to distribute that minus sign over, all over 2 sine x cos x. These cancel off. On the top, I'm left with 2 sine squared x, which is the same as 2 sine x, right? Sine squared x is just 2 sine x's multiplied together. Do we agree? Yeah, no? Okay. On the bottom, I have 2 sine x cos x. So because these are all in separate brackets, the 2's can cancel off. 1 sine can cancel off. And what is sine x divided by cos x? 10. Okay, example 3, I'm going to get you to do B. We will do A together after B. You try B. If we look at B, we have to rewrite it always. You can't, so what happens is a lot of people will start working on it without rewriting it. You have to rewrite it because you're considering this expression. You're not considering the next expression one step away from that expression. So your first step is to always rewrite it, then work with it. Okay? Because we're considering this expression, we're not considering 2 sine x cos x. That's our next step. Okay. So sine 2x is 2 sine x cos x. Then we could replace cos 2x with the one that is a minus sign, which would be 2 cos squared x minus 1. Rachel made a good point, and if you want to do this, you can as well. You can just rearrange the cos 2x formula to move the 1 over. So for example, some people, this is mind-blowing to you, so if you think this sucks, or you can't wrap your brain around it, don't do it this way, but it is actually faster. So I have 2 cos squared x minus 1. I can add this 1 over and get cos 2x plus 1 equals 2 cos squared x, and just replace the entire thing with 2 cos squared x. That's if you can spot that. If you can spot that, way faster. If you can't spot that, replace and then cancel the 1. Which way is better? Whichever gets you the right answer is always the answer. Okay? This one is faster, so I'm going to show this one for now. So we can replace this entirety of cos 2x plus 1 with 2 cos squared x. I do find it easier if people put each of these things in their own brackets, and I'm going to prove this one without writing the cos x twice, because I want to show that you can just cancel a squared off with a cos x, right? Because that is the same. So the 2's can cancel, the squared can cancel one of these, and I'm left with sine x over cos x, which is what? Tan. All right. Going back up to the non-permissible values, I have 2 cos squared x in the denominator, yes? That's what matters. So we're at 2 cos squared x is really what only matters, which I could rewrite as 2 cos x, yes? The denominator can't equal 0. The numerator can equal 0. It's totally fine, but the denominator can't. So let's talk about restrictions. Okay, 2 can't equal 0. True statement, no one cares. Okay, then we have cos x can't equal 0, and then we have cos x can't equal 0. Do I have to do it twice? If they're both cos x? No. So I just have to do it once. So I just have to do where cos x can't equal 0. So where does cos x equal 0 at? When x equals 0, which is 90 and 270. So my general form would be x can't equal 90 degrees plus how much to get to the next one? 180 degrees and EI. Exactly. Okay? So you're just stating all those spots where cos x can't equal 0. And we're going to flip over. All right. I'm just waiting for people to copy down. Okay, flip over. So this is what I said the formulas are actually good for. Determine the exact value. This is going to be the huge part. I'm going to ask you for exact value, which means go to unit circle. You can't give me the exact value of any trig function if it's not on the unit circle, but you could type it into your calculator and give me a decimal. Yes? Decimals are not exact values. All right? The decimals are not exact values. So if I say exact value, determine the exact value of some sort of angle, I'm hugely telling you need to go to your unit circle. Okay? If radians is overwhelming to you, let's find out what the heck that is in degrees first. We're going to have to still do all of our work in radians, but can we not work with degrees and then just convert to radians the whole time? Sure. I would say let's do radians, but you won't. So I'm going to adapt to you. So if we go pi over 12 and I want to convert it to degrees, what am I going to multiply by? 180 degrees. I'm multiplying by 180 degrees on the top because I need a degree symbol, correct? Remember we're canceling off units? And then it's over pi. It's either pi over 180 or 180 over pi. I need the degrees. So this cancels off. 180 divided by 12 is 15. Is 15 degrees on my unit circle? No. But there are many friends with 15 that we can add or subtract. There are many friends with 15 that we can add or subtract that would give us 15. Okay? So for example, I could do 60 minus 45. I could do 45 minus 30. I could do 135 minus 120. I could do 150 minus 135. Like there's numerous options I could choose. Yes? If I have options, I will pick the quadrant 1 every day, all day if I have options, because quadrant 1 has all positive answers. I don't have to try and deal with minus to minus or anything like that. Okay? So if I get options, that's what I do. You can pick anything. Okay? So it is sine pi over 12. Guys, listening to me. Sine and cos Whether you pick 45s or 30 degrees or 60s makes no difference. Tans do. We're going to deal with tans in a second here. But tan 60-degree reference angles, we're going to write this up here to help ourselves out. Tan of 60s is root 3. Tan of 30s is root 3 over 3. I can tell you which one I would rather work with. One is a fraction, one is not. Sometimes you don't have options of what to work with, but if you do have options, I'll pick tan 60 any day. Okay? Cotan, I'll pick 30, because cotan of 30 is root 3. Okay? All right, that's just a side note. We're going to leave that sit there. Okay, so I can pick anything. I'm going to go sine 60 minus 45, because I just felt like saying that. So I'm going to go sine of 60 minus 45, but this is in radians, so this has to be in radians. So what is 60 in radians? Pi over 3. All 60-degree reference angles are over 3. All 30s are over 6. So pi over 3 minus pi over 4. Could I go pi over 4 minus pi over 3? 45 minus 60? What would that get me? Negative 15. Did I want negative 15? No, I wanted positive. So I have to go 60 minus 45. Okay? Cool. Do you want to know how many people in the next step do this? Do not do this. You can write it and then cross through it viciously to make you not do this. Sine pi over 3 minus sine pi over 4. They distribute in. That is super false. Now, because you won't believe me, go to your calculator, type in sine of 15. Put your calculator in degrees. Go sine 15 degrees and get a decimal. Okay, got a decimal? Now go sine 60 degrees minus sine of 45 degrees. Type it into your calculator. Do those decimals match? No, because it's not true. So many people on the test, because you see brackets, it screams distribution. You want to distribute. That is not a real thing. So stop, put this on there and put a line through it, so at least maybe you'll stop yourself. Because 100%, that is the error which will happen. I promise you, half of you probably did it already. Okay? So instead, you need to remind your brains that when I see sine of two angles added or subtracted, I need to go to the formula sheet. Okay? I'm going to treat this like it's x, and I'm going to treat this like it's y, and I'm going to write out the entire formula to help my brain out first. Okay? So I need a sine x minus y. I need sine x minus y. And what is the formula for minus? It's sine x cos y minus cos x sine y. Do we agree? So when I see a sine something minus something, I can't distribute. I just proved to you you can't. Sine 15 did not give me the same answer as sine 60 minus 45, right? We all agree. So when you do that on a test, you know you're just instantly wrong, right? So we don't want that to happen. And I'm pushing it so hard because it happens all the time. The answer to that will be on the test, just so you know. It will be wrong, and we'll all be sad, but you won't know to be sad because the answer will be there. Okay, so we don't want that to happen. So I'm going to have, don't know why I have an equal sign running down this side. So I have sine pi over 3 minus pi over 4. And now I'm going to go sine pi over 3, because that goes, this is my x, this is my y. Sine pi over 3 in brackets times cos pi over 4. Now some people are like, well, I'm going to use negative pi over 4. We don't use negative. Everyone paying attention? Because this will happen. Look, this is x, this is x, this is subtraction sign, this is subtraction sign, this is y, this is y. Do you see that? So your y is positive. Subtraction sign is the subtraction sign, x is positive. Do you see that? So we're not putting in negative pi over 4. Do you see why we don't do that? You have to understand why, because lots of people will put in negative. You aren't. It would be positive, subtraction sign, positive. Okay? So we have sine pi over 3, cos pi over 4, minus sine, cos pi over 3, sine pi over 4. And now we can go to the unit circle and get those values off of it. Okay? So what is sine at pi over 3? What is sine at 60 degrees? Root 3 over 2. Your answer is root 3 over 2. That's what you all just said to me, right? Then on the test, you guys write sine root 3 over 2. And you kill the question immediately. You're like, I've heard it so much. This happens. And then you get decimals, and you're like, I can't get an exact value. That's because sine pi over 3, when I ask that to you, you guys say that answer is root 3 over 2. So we put a root 3 over 2. Close bracket. We agree, right, Levi? Mm-hmm. And then cos of pi over 4 is what? Root 2 over 2. Minus cos of pi over 3 is a half. Sine of pi over 4 is root 2 over 2. So do you see there's no sine or coses left anymore because you're literally filling in the answer from off the unit circle? We agree? A lot of you will leave the sines and coses there, and then it turns into this decimal crap, and it's all sad. So sad. Okay. The great thing about these is they'll always cause you to have common denominators, so you don't have to make them, which is super fantastic. Okay, last year in grade 11 you were taught that when we multiply root times a root, we multiply the coefficient times the coefficient, the radicand that's underneath times the radicand that's underneath. So 1 times 1 is 1. I don't need to write it. Root 3 times root 2 is root 6 over 2 times 2, which is 4. Watch yourself. A lot of people will go 2 times 2 and they write 2. It's just a common error. You know 2 times 2 is 4. I do it myself sometimes because you just write it out. It's not. And then 1 times root 2 is root 2 over 4. And now it's all over 4. So it's root 6 minus root 2 over 4. Done. Now, we walk away knowing we're correct or not, because what can I do? Type that into my calculator. That should give me the answer that I got when I put in sine 15. Do not give that answer on the test, though, because it's a decimal and not an exact value, right? But you should know if you're right or to cry. There's no in between. Hopefully it is to be right and not to cry, because we don't want that. Same answer is sine of 15, right? Okay, cos 165. I want you to try it out. You can find 2 numbers that add to get me 165, or you can do 2 numbers that subtract to get me 165. I do not care what version you do. I want you to do whatever you would do. Okay? So we're trying to get 165 degrees here. So it's going to be cos something, something. You can be adding or subtracting, whatever you want. We should all end up with the same answer is the key. Or maybe you don't get stuck and you just rock it. Whatever. The catch with tan 105 is I want a rationalized denominator. And my hint to you is I would use a 60-degree reference angle. Because a 30 makes you have fractions embedded in a fraction. Because the addition and subtraction for tan is a fraction formula. You'd end up with fractions in your numerator and fractions in your denominator. So personally, when I get the choice, tan 105, I need a 60-degree reference angle. So if I'm choosing, I'm going to go tan 60 degrees plus 45 degrees, or 45 plus 60, or any version of subtraction that involves a 60-degree reference angle. So like the 120 has to be involved, or the 240, or the 300, okay? If I have to use 30s, I will, but I do not choose them, because you'll have fractions over fractions, and then you guys get super crazy overwhelmed. So try this one out. If you get stuck, you get stuck, no big deal. So we're going to get tan 60 plus 45. We are not going to distribute it and say tan 60 plus tan 45. I type that in, she don't match, right? We stop the madness. Okay, so tan plus is always addition on the top and then subtraction on the bottom. So we're going to get tan 60 plus tan 45 over 1 minus tan 60 tan 45. I personally love the 45-degree angles for tan and cotan because they're either ones or negative ones, right? No fractions. Great things. Okay, so tan of 60 is root 3 plus 1 over 1 minus root 3 times 1. Well, multiplying by 1 does nothing. So we get root 3 plus 1 over 1 minus root 3. This is grade 12. After this point is grade 11. Okay? In grade 11, we were taught how to rationalize our denominator if there's a monomial. So like if it was like a root 2, we would multiply by root 2 in the numerator, and then what we do the bottom, we have to do the top. We were also taught how to do rationalize the denominator when you had a binomial. 1 minus root 3. What would you multiply by? The conjugate, which is 1 plus root 3. Okay? So we are going to get multiplied by 1 plus root 3. Did anyone ask your teacher why? Multiplying by a conjugate gets rid of the radicals, which is what we're trying to do. Okay? Side note. Everyone pens down. I want you to understand why. So when you're stuck at this spot, you're like, oh, just multiply by the opposite sign, and this is why. If you know why, you don't make mistakes. If you know why, and you get stuck, you're like, wait a second, what can I do to get unstuck? So, whether you had 2 plus root 3, if I want to rationalize, that means I want the radicals to get out of my life, right? So, if I multiply by the conjugate, how does that fix the problem? Well, let's talk about it. So the conjugate means exact same binomial, opposite sign, right? So if there's a plus sign between, I put a minus sign now. If there's a minus sign, I put a plus sign. Why does that work? Well, 2 times 2 is a 4, right? No radicals involved there. No problems, yes? So let's talk about the outside now, though. We get 2 times negative root 3, we get negative 2 root 3. And because we use the opposite signs, our middle term is going to end up being 2 plus times root 3, which is positive 2 root 3. If we use the same sign instead of the conjugate, I would end up with 2 root 3 plus 2 root 3, which is 4 root 3, and the root 3 wouldn't go away, and I'd be in trouble, right? I need those radicals to cancel off, yes? So the reason why you use opposite signs is because your outside term and your inside term will be the exact same, but opposite signs, which means they will cancel. The other reason is where it doesn't matter that the back doesn't cancel is because you're going to multiply 2 radicals that are the same together. So root 3 times negative root 3 is negative 3. The radicals will go away because you multiply them by the same thing. Yes? So then I would end up with 1. Radicals gone, denominator rationalized. Yes? What happens if they're both radicals? So say I had root 2 minus root 3. Well, I would just multiply by root 2 plus root 3. Because my first and last terms, when I FOIL, my first and last terms will be the same roots multiplied, so the roots will go away. And we use conjugates, opposite terms, so the middles will go away. So root 2 times root 2 is 2. Then the outsides is root 2 times root 3, which is positive root 6. Then root 2 times negative root 3, which is negative root 6. Because I use conjugates, they cancel. And then negative root 3 times negative root 3 is minus 3, and I get negative 1. Still gone. So does it make sense why you multiply by the conjugate? Because the conjugate gets rid of those middle terms where the radicals still exist. And you want to get them to go bye-bye. Because the other ones, the first and the outside, even if they are radicals, they'll go away just because root 2 times root 2 is 2. So, knowing that, what am I going to multiply by? 1 plus root 3, 1 plus root 3. So let's see what we get. So, 1 times root 3 is root 3. Then we do outsides. Root 3 times root 3 is 3. Then we do insides. 1 times 1 is 1. Then we do last. 1 times root 3 is root 3. All over 1 times 1 is 1. 1 times root 3 is root 3. 1 times negative root 3 is negative root 3. And I know I'm right immediately after that step. And then negative root 3 times root 3 is negative 3. And so I'm going to get 3 plus 1 is 4. Plus root 3 is 2 root 3. And then 1 divided by 1 minus negative 3 is negative 2. Now, you can leave the negative in the denominator, but if you're trying to match a multiple choice, they will always run that negative up. So what could I take out of all three of these? And remember, it's the same as the quadratic formula. I have to take it out of all three of them. It's the GCF. What could I take out of all three? A 2. What would be better to take out to get that negative up? A negative 2. So 4 divided by negative 2 is negative 2. 2 divided by negative 2 is minus 1 root 3. And then negative 2 divided by negative 2 is a 1. Do I need the 1 in the denominator? No. Remember this. Tan 105 should equal this if I typed it into my calculator. Should equal this if I typed it in. Should equal this if I typed it in. Should equal this. Should equal this. Should equal this. If at any point in time it does not equal, like say you go to put your answer in and it doesn't equal tan 105, could I not just go back one step and see if that equals tan 105? And if it doesn't, the problem's up further. This, does it equal tan 105? Yes. Okay. Then the problem is from this step to this one, right? You can work your way back, typing those in and seeing if you get the decimal to tan 105. And you can work back until you get the right decimal. Then you know that was good and you made the error in the next step. Ways to check it. Okay, no. Run overboard. All right. Let's go to the next page. Last two examples. And then in chapter 6, you have one lesson left. Proving. Okay. This uses the rules of chapter 4. When I gave you a trig ratio and you had to find the third side and give me another trig ratio. This uses that same steps, but now there's two of them. So you know how to go like tan theta equals 3 over 4, let's say. And then I wanted sine theta, and you'd find the third side, and then you could give me sine theta. Same thing here, but this is more advanced. So here it says, given cos A, cook extra rice, and A is between 0 and pi over 2. And cos B, cook extra rice, but it's a new triangle, and B is found between these two. They want us to find cos A plus B. Guess what I do immediately? I write out the cos A plus B, and then I stop myself from writing this equal to cos A plus cos B. Are we allowed to distribute this? Are we allowed to distribute? No, we have to remind our heads that we have to do what? Tell ourselves to go to the formula sheet. Go to the formula sheet. Okay? Step 1 for these questions is formula sheet. Stop yourself from distributing. If you are going to be the distributor, you're going to get every question that involves plus signs and minus signs wrong. Because you will be wrong immediately in the second step, and therefore get like nothing. So, cos A plus B is cos A, cos B, minus sine A, sine B. So if I can get people to go to the formula sheet, I can usually get them to fill in half of the equation. Because what did they give me already? The answer to cos A and the answer to cos B, correct? So they say cos A equals 3/5. So wherever I see a cos A, I can replace it with a 3/5, correct? So here's my cos A. I can rip it off my board, huck it away, and replace it with 3/5. And a lot of people will write cos of 3/5. No. Cos A is 3/5. So take cos A, tuck it away, replace it with 3/5. Yes? Cos of B is 5/13. And then, oh crap, I get a lot of people leaving it here and saying, sorry, on the test. In the past, when I gave you a trig ratio, I told you that you needed to draw the triangles. Find the third side, yes? We are going to do that. So step 1 is formula sheet. Step 2 is draw triangles, find third side. So I have 2 triangles. I have an A triangle and a B triangle. My A triangle, cos A is found between 0 and pi/2, so that's the first quadrant. This is my A triangle. And I'm going to deal with that in a second. I also have a B triangle. It is found between 3 pi/2 and 2 pi, so that's in quadrant 4. We make bow tie triangles always. This is my B triangle. The A triangle is found between 0 and pi/2 right here. The B triangle is found between 3 pi/2 and 2 pi. Yes? Does everyone follow that so far? Okay, let's fill in what we know on these triangles. So we're going to deal with the A triangle first. I know it's x over r because cook extra rice. So I know I have x equals 3. I know I have r equals 5. And I know I have y equals positive something. These are the nice triangles. It's the 3, 4, 5 triangle. But if you don't recognize that, you can solve it. Y squared equals 5 squared minus 3 squared. Y squared equals 25 minus 9. Y squared equals 16. Square root plus or minus. Square root plus or minus. And because I drew the triangle, I know it is positive 4. I am not going to move on to B yet. I'm going to fill in sine of A. Based off that triangle, and that being the A triangle, do you see how I label it A and I label the other one B to help my brain out? What is sine of the A triangle? Sine is sign your resume. What is sine of the A triangle? Sine A equals sign your resume. 4 over 5. Is that true? Sign your resume. It's 4 over 5. So I can go here and I can go 4 over 5. You see that? Yeah? Okay, what about B? So B is cook extra rice. So my X is 5. My R is 13. And because I drew the triangle, I know my Y is negative something. If I don't draw the triangle, I'm going to put positive something. Do you think the answer to that will be there? It will. It'll be a sad day. You'll have done all the work for no reason. Okay. So I need to find that third side. So y squared equals 13 squared minus 5 squared. Y squared equals 169 minus 25. Y squared equals 144. I take the square root with my own hand, so I do plus or minus. So y equals negative 12. So what is sine of B? There's my B triangle. I need sine B to fill in. What is sine of B? Negative 12 over 13. Once again, whenever using the adding and subtracting formulas for sine and cos, you should have common denominators after this point. If you don't, you screwed up. So I'm going to get 15 over 65 plus 48 over 65, which equals 63 over 65. You have no way of checking this. The other ones you could go like tan 105, sine whatever, blah, blah, blah. There is no way you can check this. You got to believe in yourself and do the question right. Example 6, I am leaving for tomorrow because if I teach you 5 and 6, then you can't do 5 or 6. You get them mixed up, and then it's like a mumble-jumble mess. So I'm going to let you work on 5 tonight. Do your freaking homework. Do your awesome homework. Frogging homework, you know. And then 6 we will do tomorrow. Yeah? Okay. The homework is listed here. I'm just going to check and see because I'm going to downgrade it, unless you whine right now. Then I'm just going to let it sit and brew.